But right now, up along the way. So this is an allotment problem. We haven't done one of these in a while. This is an old test, so it's a sample of an old allotment problem. So Tanner, how'd you start it?
Well, I knew Kelly had 40 acres.
Right, so if you read, and you should make sure to read carefully, that's the important information. The plot below is divided into acres for 6 farmers. Farmer Kelly owns 40 acres. So right away, you know that this is 40. Find and record the following in the table: the fraction of land each farmer owns and the acres each farmer owns. I would do the acres first. It's easier for most people. So how do you use that 40 with the chart, I guess, with the picture?
So, Irvine, if you take 2 40s,
Yes.
you divide it like it.
Okay. So you're kind of looking at some rectangles, it looks like to me.
Mm-hmm.
Let's put a picture to that for people. So maybe we have this size that Kelly has is a 40, and it sounds to me like you see a few of these in Urbox here.
Mm-hmm.
So we know she's got 80 plus a little bit more, right? What's the little bit more?
I'd say that was about 20.
So, and you could probably check that, right? I agree with you. It looks like it's about 20. Let me try that again. So if we just picked another one again, so you can kind of visualize what he's talking about. He's saying this looks like it's about 20. I agree, because if you think about this, you could rotate this, and on your paper you could draw lines, right? I'm doing this just to kind of show you how it fits in, but we'll also look at how you could do that on your own paper. So do you see the 20s and the 40s?
Yeah.
Once you know those two pieces, you know all kinds of things. So if we remove these, because you don't have a smart board to play with while you're taking the test, unfortunately, and keep just Kelly in place, what you could do is you could take a pencil, a nice thin pencil line, and draw on your picture, but you don't need to draw crazy. Do what Tanner was doing. You know, break it up into parts, but don't like go so crazy that you can't read what you have. Also, you notice I used a really light color because I don't want to get my pencil so dark that I can't tell the original borders. That's frustrating. Then you won't be able to see. So we know that this little piece was 20 here, and these were 40 each. So Urbach altogether has 100. Kelly has 40. Does that make sense? So Maya, do another section.
Okay. Can I do Morris?
Sure.
So, I see 80.
It's, yeah, because with the same size of Kelly's, you see 2 of those in there, don't you?
Mm-hmm.
So I think everybody would agree with you. Each of those is 40, right? So altogether, Morris has an 80. Grace, how about you? What do you see?
Van Orts.
Okay. How would you divide Van Orts?
It looks like a second box.
Kind of like the panhandle. I call it the panhandle. It's not funny. Right here, 20. Good. So this is 20. And what about that?
I thought it looked like a 40. It looked like it was folded.
So let's take a look at that idea. So you mean It's like 2 of these,
Yeah, but like side to side.
side to side. You still think so? No, so, but with the pencil, could you do this? See this down here? Could you kind of use some of these other lines here?
Yeah, that's good.
Would that help you? And then I bet you could see another one right here. Does that make sense? So now you have 20, what's this part? 20 and 20 and 20, so altogether Van Ord has 80. Okay. So Melanie, how about Rayleigh? How much? 20 on one side, 20 on the other, right? 20 here and 22 here, so altogether 40. Nice. And then Pryor. How about Jeff? What'd you get for Pryor?
For Pryor, I got 60.
Good. 60. Okay, so you can fill, let me make this a little smaller. You can fill in part of the table now. Van Ort has 80. I spelled that wrong. These are 8th graders. I gave this test to them when they were in 6th grade. Morris has 80. Rayleigh has 40. What about Kelly? 40. Pryor? 60. Urbach?
100.
100. Okay, raise your hand if that makes sense. Okay, so let's get rid of all these chunks here and talk about fractions. You know, you could do a small ratio table off to the side. You have a little more room on the right side of your paper than I do. But just start with 80, and you're comparing the part to the whole, so you need the whole. You need to know the total to figure out the fraction. So you would have to add all of these numbers, all the acres up. What do you get, Jeff?
In all, I got 400.
What'd you get, Jason?
400.
Okay. What'd you get, Bryce? Did you get 400?
For the acres?
Mm-hmm.
You said it's 100 when it shouldn't be 60.
For Pryor?
That's 60.
I have 60.
No, that's for Irma. No, under Irma. Oh, I'm stupid. When he wrote it, it's like one number.
But did we all agree the total's 400 when you add all those numbers up?
Yeah.
Okay. So we're going to use that total to do fraction reducing. First, it's so easy to reduce by 10, isn't it? That would be 8 out of what?
40.
40, right? And then you could keep simplifying. Yes, Sophia?
You could do divided by 2, and that'd be 4 and 20, and then you times it by 5, and that'd be 100.
But we don't want a percent, we just want a fraction.
Oh, okay.
So can you keep going?
Yeah. And you could divide it by 2 again, and that'd be 2, and that'd be 10.
Can you go again?
Yeah. You divide it by 2, and that'd be 5.
So this is a fifth of the whole area. So let's do a different one. You only really need to do a few. Like this is a fifth because they're both 80 acres, right? Yes, TJ.
Like Kelly and Rayleigh both be 1/10?
They would be because they have half as much, right?
Yeah.
Half of a fifth is a tenth. If you have trouble with that, you could start again and just do 40 over 100 is the same as 4 over 10, which is the same, 40 over 400, I'm sorry, is the same as 4 over 40, which is the same as 1 over 10 if you divide by 4, right? So he's right. Now, if you know half of a fifth is a tenth, you could skip the ratio table and just write in a tenth here, a tenth here, and then go to the next one. How about 100 out of 400? Yeah, Jason.
Isn't it 1/4?
Yeah. 100 out of 400 is the same as 1 out of 4. So we need to do one more. I'll do it right up here. 60 out of 400 is the same as what?
640.
6/40, which is the same as 3/20. Good. So 3/20. So that's one allotment problem. The next two things we're going to look at are 2 and 3, and then I'm going to save this and post it as just allotment problems, so it's not a super long video. That way, if you get stuck studying, you can look at that. Okay. Does anybody remember how to do 2 or 3, or have some ideas of how to start that? Okay, Nathan, what would you do? Which one?
So 2, I would add up the outsides first. And since I know that 4 times 4 equals 16, and I know that given each square is 10 centimeters.
Okay, so the reading's important, right?
Yeah.
Each square is 10 centimeters.
Yeah.
So altogether there's, so that means each little square here is 10 centimeters like that, right?
Yeah.
So that's 10 centimeters. And so there's 16 of them. You could do that.
So there would be the total of all the squares to be 160.
Right, so for some people that would be good to get the total first. The total would be 160 because there's 16 squares. How are we going to handle that shape, Jack?
Well, so, anyways, after I got 160, I divided it by 2, and
Yeah.
I got 80, and I figured that it should be around 80.
It's actually exactly 80, so could you...
Oh, wow.
So let's look at why. So good job. Does anybody notice anything when I trace on here about this shape here?
Oh!
What do you notice, Sam?
Well, I noticed that if the outside of that trace, like on the corner,
Yeah,
you can set it
I can rotate it.
to that side.
I can make it go here, right?
Or you can also take the sides. Where
Okay, let's do one thing at a time. Which one would you do? This? The side, so not what I just did. Tell me what you would do.
So I took the side where it's curved in.
This part?
Yeah.
Uh-huh.
And I put it behind the curved part.
Okay, so he took, let me get another kind of another brighter color here. Well, you just take yellow again. He took this piece. You see this? And he pieced it in here.
I see it.
So together, which means he would have to get rid of it here, right? Because that's gone now. But it is included here. That works, Sam. That works great. And then what?
I did to both sides.
You would do the same thing, wouldn't you? So he would take this piece here. So he did the same thing here. So take this one. And you're going to rotate it to fit in the upper right corner, which means you have to imagine that you cut that off here. But then you piece it in here, right? And each little square is 10 units, remember? So that means either you can do what Nathan did, divide this in half, get the total and divide it in half, so you get 80 units, Or you could count up 10, 20, 30, 40, 50, 60, 70, 80 units, and you'd get 80 squared centimeters. Does that make sense? So you should draw on your, this word test question. I expect to see some drawing on it. Yes, Sophia?
Can you draw it like so for that shape? Can you draw it like it's filled in?
Yeah, you could have just the top filled in,
Yeah.
top half. There's more than one correct way. Okay, last problem before I stop this recording, and then I'm going to have you guys do a little independent work. When we did the problems like number 3, we used rectangles. Do you remember that? We looked at the outside of, say this, like right here, we would look outside and look for triangles that fit in perfectly here. Does anybody remember doing that? So, I'm not sure if I'm explaining that very well. So do you see that this has an area of 2 units? Can you see that? So that size of shape worksheets that we did before, do you remember the worksheet? So a triangle like this one on the right here, this little triangle here, it's half of this rectangle there. So Leslie. Same with this one here, right? It's the exact same size triangle. Do you see any others, or are those the only 2? So how much does each one of those triangles make up?
2.
Well, they make up 1. Together they make up 2. Because, Sophia, the triangle, if you think about it, is just half of the rectangle. The rectangle is 2 units. So the triangle's 1. Is that what you meant? Together they make 2? Yes, I agree. So then what's this square? This one's just, what's the square? 1, right? So what about that square? 1. But now we have a bigger triangle, right? 2 bigger triangles like this one. So we need a bigger rectangle. So we're going to take this rectangle and stretch it out. And how big is that rectangle? 4 units, right? So this triangle out here, this triangle out here is half of that, right? So what's the area of this triangle? 2. What else? Is the last triangle the same or different than both of those? It's different. So Zoe, what do you think it is?
Like the
This?
area?
Yeah.
I think it's
Huh. Stressed the wrong thing.
of that triangle. Or,
Yeah, so this triangle up on top there. So let's get this kind of, the rectangle. See the rectangle here?
yeah, it's half of this.
And how much is that rectangle?
It's 3. So
3.
It's half.
So half of 3 is 1.5. So what do we do with all those numbers, Sean?
You add them and then times it by 10.
Okay, good. Yes, you add them. In this problem, I think I could have done better on the wording, but it doesn't say each one is 10. So I should say each one is 1 unit. Like I should have had that in there. So let's assume they're all 1 unit. I'm going to add them. So 2 plus 1 plus 1. So 2, 3, 4, 5, 6, 7.5. What do I do with that, MJ? The outside triangles add up to 7.5. What's the whole grid add up to?
16.
So what do you do, MJ?
So you divide 16, or that's 16 by 7.
Yeah, you take 7.5 away from 16. So what's 16 take away 7?
It's 8.5.
Well, what's 16 take away 7? 9. Now take another half away. 8.5 square units, right? That's the yellow. We did a lot of problems like that, but we haven't done them for a while. So that's something you should definitely study. I'm going to post